On Earth, sleep begins with something so ordinary that we almost never think about it. Weight. Your body sinks into a mattress. Your head presses into a pillow. A blanket rests across your chest and legs. Even before your eyes close, gravity quietly tells your brain where you are. Down is beneath your back. Up is above your face. Your muscles can relax because the bed is holding you in place. That simple pressure becomes part of what comfort means. But in orbit, this familiar language disappears. An astronaut preparing for sleep is not lying down in the usual sense, because there is no true down for the body to settle into. The station, the sleeping bag, the astronaut, and everything around them are all continuously falling around Earth together, creating the condition often called microgravity. Gravity has not vanished, but its familiar pull on the body is no longer felt in the same everyday way. That is what makes sleeping in space so strange. The problem is not only finding a place to rest, but convincing a human body that rest is even happening. Imagine closing your eyes while floating inside a quiet machine above Earth, with your arms drifting unless they are tucked away, your legs not pressing against anything, and your back receiving no signal from a mattress. On Earth, a bed does more than provide softness. It gives orientation. It tells your nervous system, you are safe, you are supported, you can stop holding yourself up. In space, that message has to be created artificially. Without weight pressing the body into a surface, a soft mattress would not work the same way. A pillow would not support the head in the normal sense because the head is not being pulled downward. A blanket would not naturally stay spread over the body. Even the idea of rolling onto your side loses much of its meaning when your body is not resting against a horizontal plane. This is why the first surprise about space sleep is that comfort becomes less about softness and more about stability. The astronaut does not need a bed to prevent pain from pressure points. They need a system that keeps them from drifting, bumping into equipment, blocking ventilation, or waking up with their body turned in an awkward direction. In microgravity, a sleeping person can float gently, but floating freely is not necessarily relaxing. Human sleep depends on reducing uncertainty. If the body is moving without clear feedback, even slightly, the brain may not interpret that as restful. Some astronauts adapt quickly, while others may take longer, and sleep quality can vary for many reasons: mission schedule, noise, light exposure, stress, workload, and individual biology. The deeper point is that space does not remove the need for sleep. It removes many of the environmental cues that normally make sleep feel natural. Inside a spacecraft, every ordinary bedtime habit has to be reconsidered. Where do you put your hands if they keep floating? How do you know your body will stay where it is? How does the brain understand night when the station circles Earth many times in a single day? Before astronauts can sleep comfortably, they first have to replace the silent assistance that gravity gives everyone on the ground. That is why sleeping in space looks simple from the outside, but is actually one of the most revealing parts of human spaceflight. It shows that comfort is not just a mattress, a pillow, or a dark room. Comfort is a relationship between the body and its surroundings. On Earth, gravity builds that relationship for us. In orbit, astronauts have to build it themselves. And that leads to the central question. If nothing is pulling the body down, how do astronauts stay still, feel secure, and sleep for hours while floating hundreds of kilometers above the planet? In space, the closest thing to a bedroom is not a bed at all. It is usually a small sleeping station, a quiet compartment just large enough for an astronaut to float inside, close the door or curtain, and separate themselves from the busy machinery of the spacecraft. Instead of lying on a mattress, they climb into a sleeping bag. But this sleeping bag is not used the way it would be used on a camping trip. On Earth, a sleeping bag keeps the body warm while gravity keeps the person on the ground. In orbit, the sleeping bag becomes something more important, an anchor. It gives the body a fixed place in an environment where drifting is normal and stillness has to be created. The bag can be attached to a wall, a ceiling, a floor, or the inside of a personal sleep compartment. Those words sound strange on a spacecraft because in microgravity, a wall and a ceiling are not felt the way they are on Earth. A surface is simply a surface. What matters is not whether the astronaut is upright or lying down, but whether the body is gently secured. The purpose is not to stop them from falling, because falling in the normal household sense is not the problem. The purpose is to stop them from floating into equipment, bumping into another object, blocking airflow, or waking up in a different position from where they started. A sleeping astronaut may look peaceful, but the design around that sleep is practical and carefully controlled. Inside a sleep station on the International Space Station, comfort is built from small details. The space is compact, often compared to the size of a small closet or phone booth, but it gives something extremely valuable in orbit: privacy. There may be a sleeping bag, a small light, ventilation, a laptop, and a place for personal belongings. These things may seem ordinary, but in space, they carry extra meaning. A laptop can connect an astronaut to work, messages, music, or family. A small personal item can make a machine-filled station feel less distant from Earth. A lamp gives control over the environment. An air vent matters because air does not behave in microgravity exactly as it does in a bedroom on Earth. Fresh airflow helps keep the sleeping area breathable and comfortable. The pillow is where the difference becomes even clearer. On Earth, a pillow supports the head because gravity pulls the head downward. Without that familiar pull, the head does not press into a pillow in the same way. The neck is not carrying the same load, and the body does not need soft support under the head to prevent it from dropping. Some astronauts may still use a small pillow, padding, or straps, not because the physics demands it in the same way, but because the mind likes familiar signals. A gentle pressure near the head or back can make sleep feel more normal. In that sense, the pillow becomes less of a support tool and more of a psychological bridge between Earth and orbit. This changes the meaning of comfort. On Earth, people often describe a comfortable bed as soft, warm, wide, and heavy with blankets. In space, softness alone does not solve the main problem. A floating body does not need a thick mattress to protect it from pressure against the ground. What it needs is orientation, quiet, airflow, and the reassurance that it will stay in one place. The sleeping bag gives the astronaut boundaries. It says, in a silent, physical way, "This is your place for the night." That boundary matters because the rest of the station is full of motion, fans, equipment, schedules, and floating objects. So the sleeping bag replaces the bed not by copying it, but by doing a different job. A bed on Earth supports a body against gravity. A sleeping bag in orbit organizes a body in the absence of that familiar pressure. It turns floating into rest. It gives a person a small private zone inside one of the most unusual environments humans have ever lived in. And once the astronaut is zipped in, secured, and surrounded by a few familiar objects, sleep becomes possible not because space has become normal, but because the body has been given enough stability to let go. One of the hardest parts of sleeping in space is not the floating itself, but the environment around the sleeper. On Earth, night usually arrives slowly. The sky darkens, the temperature changes, homes become quieter, and the body receives a familiar signal that the day is ending. On the International Space Station, that natural rhythm is broken apart. The station travels around Earth roughly once every 90 minutes, which means astronauts can experience many cycles of sunrise and sunset in a single 24-hour day. Outside the window, Earth may move from darkness to bright daylight and back again with a speed no human body evolved to follow. The view is beautiful, but beauty is not always restful. A sunrise over the planet can be breathtaking, yet for the brain, repeated light changes can become confusing when it is trying to decide whether it is time to wake or sleep. Human sleep depends strongly on circadian rhythm, the internal timing system influenced by light, darkness, routine, and body chemistry. In space, astronauts cannot simply trust the sun to tell them when the day is over. Instead, they live by a carefully planned schedule. Work, meals, exercise, communication, and sleep are arranged according to mission time, not according to the fast-moving sunrises outside. This artificial structure is not just a matter of convenience. It helps protect alertness, mood, performance, and long-term health during a mission. When the body cannot rely on a normal day-night cycle, discipline becomes part of the sleep system. Lights inside the station can be adjusted, and astronauts may use sleep masks to block unwanted brightness. Small habits also matter: ending work, preparing the sleeping area, limiting distractions, and repeating the same bedtime pattern when possible. These routines give the brain a substitute for sunset. Noise is another challenge. A spacecraft is not silent at night. Fans, pumps, computers, cooling systems, and life support equipment continue operating because the station has to remain alive even when the crew is asleep. Air must keep moving. Temperatures must be controlled. Equipment must keep running. That background sound may not be dramatic, but it is constant. On Earth, people often sleep in rooms where air settles naturally and silence can deepen after midnight. In orbit, still air can be unsafe, and silence would mean something is wrong. Ventilation is especially important because, without normal convection, exhaled air does not rise and disperse in the same familiar way. Moving air helps keep the breathing zone fresh, but it also adds to the mechanical soundscape. For this reason, astronauts may use earplugs, headphones, or other simple tools to reduce disturbance. The deeper truth is that sleeping in space is not passive, it is engineered. A good night's rest depends on lighting, airflow, sound control, scheduling, and personal routine, all working together. The sleeping bag holds the body in place, but the environment must hold the mind in place. Spaceflight turns sleep into part of mission safety, because a tired astronaut is not just uncomfortable, they may be less focused during complex tasks. Rest becomes another life support system, quieter than oxygen or water, but just as connected to survival. In space, sleep is not merely the end of the day. It is a carefully protected operation inside a machine that never fully stops. When an astronaut sleeps in orbit, the body is not simply resting in a new place. It is resting under a new set of physical rules. On Earth, gravity constantly pulls fluids downward, loads the spine, presses the body against a mattress, and gives the brain a clear sense of posture. In microgravity, many of those signals become weaker or disappear from normal awareness. The astronaut may be asleep, but the body is still adapting to an environment it was never naturally built for. One of the most noticeable changes comes from the way fluids move. On Earth, blood and other body fluids are influenced by gravity, so more fluid tends to collect in the lower parts of the body when a person is upright. In orbit, that downward pull is no longer felt in the same way, so fluids can shift more toward the chest and head. This is why astronauts may appear to have a slightly puffy face, especially during the early part of a mission. Some also describe a stuffy nose, or a feeling similar to having a mild cold. During sleep, this headward fluid shift can make the body feel unfamiliar. The astronaut is not lying flat, yet the face and upper body may feel more filled than they would on Earth. The spine also behaves differently. On the ground, the spine is gently compressed all day by body weight. When a person lies down at night, some of that compression is reduced. In orbit, the spine is unloaded much more continuously, so astronauts can become slightly taller during a mission. This change is usually temporary, but it shows how deeply gravity shapes even the quiet structure of the body. Sleep in space does not require the back to sink into a mattress because the back is not carrying weight in the same way. That sounds comfortable, but it can also feel strange. The body loses the familiar pressure that normally tells it you are lying down. Muscles experience a similar shift. On Earth, even resting involves subtle work. Muscles help stabilize posture, support limbs, and respond to the pull of gravity. In microgravity, the body does not need to hold itself against the bed or maintain a normal sleeping position. Arms and legs may float unless they are inside a sleeping bag or gently restrained. This is one reason astronauts often secure themselves before sleeping. The goal is not only to avoid drifting away, but to give the body a calmer, more predictable shape. The brain has to interpret all of this. Normally, the inner ear, joints, skin, muscles, and pressure points help the brain understand body position. In space, those cues can conflict or become less clear. There is no ordinary feeling of lying down, no natural heaviness of the blanket, and no strong pressure from the mattress. Some astronauts adjust well, while others may need more time. Sleep quality in space can be affected by many factors at once: light cycles, mission schedules, background noise, stress, workload, exercise timing, and individual biology. It would be too simple to blame one cause. What makes space sleep so fascinating is that the body can still find rest, even when many familiar signals are missing. The astronaut's body does not stop needing recovery. It simply has to recover without gravity doing its usual quiet work. In that sense, sleeping in space reveals something easy to overlook on Earth. Rest is not just closing the eyes. Rest is the body trusting its environment enough to let go. By the time an astronaut learns how to sleep in space, the lesson is no longer only about the body. It becomes a lesson about the mind. A sleeping bag can hold a person in place, a schedule can control the day, and ventilation can keep the air moving. But none of those things alone make a spacecraft feel like home. Comfort in orbit comes from turning a highly technical environment into something human. Inside a small sleep station, an astronaut may keep family photographs, a personal item, a laptop, music, or small objects that carry meaning from Earth. These details do not change the physics of microgravity, but they change the emotional texture of the space. A metal compartment becomes less like a machine and more like a private corner of life. The personal crew quarters on the International Space Station are small, but their value is much larger than their size. During the working day, astronauts live in a shared environment filled with equipment, experiments, checklists, cameras, and communication with mission control. Privacy is limited. Every task has a purpose, and every object must be controlled. At night, the sleep station gives the astronaut something rare: a boundary. It is a place where the mission becomes quieter, where the body can stop performing, and where the mind can briefly return to itself. Even a small door, curtain, light, or personal screen can help create the feeling that this is not just a station orbiting Earth, but a room. Bedtime in space is usually not random. Astronauts follow structured routines because routine helps replace the natural signals that orbit takes away. Before sleep, they may complete hygiene, secure loose items, check equipment, communicate with the ground, write messages, or talk with family when schedules allow. These actions may sound ordinary, but in orbit, ordinary things become stabilizing. Brushing teeth, changing clothes, dimming lights, or preparing a sleeping bag are not just chores. They are signals to the brain that the workday is closing. When the sun rises and sets many times outside the window, routine becomes the astronaut's artificial sunset. The emotional side of space sleep is easy to underestimate. Astronauts are trained professionals, but they are still human beings living far from home in a place where almost nothing behaves naturally. There is no soft bed waiting under them, no floor to step onto in the morning, no quiet neighborhood outside the window, and no true night surrounding the station. The sounds of machinery continue. The airflow continues. The planet moves below them in silence. To sleep there, they need more than engineering. They need trust. Trust in the spacecraft, trust in the schedule, trust in the team on the ground, and trust in their own ability to adapt. That is what makes the final image so powerful. A person zips into a sleeping bag attached to a wall, closes their eyes inside a small compartment, and sleeps while moving around Earth at orbital speed. Nothing about it resembles a normal bedroom, yet somehow it becomes one. The strange truth is that humans can carry the idea of home into places where home should not exist. In space, comfort does not come mainly from a mattress, a pillow, or a blanket. It comes from stability, privacy, routine, and memory. It comes from the quiet human ability to turn even a weightless room above the planet into a place where the body can finally